In this video, Professor Wellens and myself will present you two examples of atypical ventricular preexcitation. In this slide, we show the 12-lead electrocardiogram of an example of atypical ventricular preexcitation due to an inferior paraseptal accessory pathway. In this case, preexcitation is atypical only because the PR interval is not short. In our example, as you can see here, it is 150 milliseconds. Otherwise, the rest of the electrocardiographic characteristics in this example are of typical preexcitation. That is to say, the QRS complex is wide. In this case, it is 120 milliseconds, and there is a visible delta wave, as you can see here. The atrioventricular conduction times over the accessory pathway are 150 milliseconds. This is the typical part. Why are they a little bit long for an accessory atrioventricular pathway? Most likely because atrioventricular conduction times over this paraseptal, left-sided paraseptal inferior accessory pathway are prolonged. We have postulated 80 milliseconds through this accessory pathway and 70 more milliseconds to arrive from the sinus node to the atrial insertion of the accessory pathway, making a total of the 150 milliseconds. Note that the delta wave in this example is a little bit less than 40 milliseconds. Most likely it is around 35 milliseconds. So the atrioventricular conduction times over the normal AV node His pathway are 185 milliseconds. That corresponds to 150 of the PR interval plus the 35 milliseconds of the duration of the delta wave. We have postulated 45 milliseconds from the sinus node to the entry of the AV node, 90 milliseconds to cross the AV node, and 50 additional milliseconds to reach the ventricles via the bundle branch system. In this slide, we present an example of very atypical ventricular preexcitation. Very atypical because the PR interval is not short and the QRS complex has a duration of less than 120 milliseconds. In our example, the PR interval was 130 milliseconds and the QRS complex had a duration of 100 milliseconds. We had a delta wave. The delta wave was not as evident as in the example of atypical ventricular preexcitation that we discussed before. The duration of the delta wave in this case was of about 20 milliseconds. The PR interval was 130. Why the PR interval was in this case longer than 120 milliseconds, was a little bit long? Because this patient had a left lateral accessory pathway. That is to say, the accessory pathway was far from the sinus node and it took 85 milliseconds to reach the atrial insertion of the accessory pathway. We have postulated 45 additional milliseconds to cross the accessory pathway to arrive into the left ventricular myocardium, making a total of 130 milliseconds. Since the delta wave lasts for about 20 milliseconds and the PR interval is 130, this makes 150 milliseconds for the atrioventricular conduction times through the normal AV node His pathway. We have postulated 40 milliseconds from the sinus node to the entry of the AV node, 65 milliseconds to cross the AV node, and 45 additional milliseconds to arrive in the ventricular myocardium via the bundle branch system. why the QRS complex is wide? The reason is the atrioventricular conduction times via the AV node His pathway are only slightly above those over the accessory pathway, 20 milliseconds of difference. Therefore, a QRS complex that would have been 80 milliseconds in duration, now, because of the delta wave of 20 milliseconds, has a duration of 100 milliseconds. Finally, note that by pacing at a rate of 120 beats per minute from the high rate atrium, we have increased the degree of ventricular pre-excitation, because at this rate we prolong the conduction times over the AV node while the atrioventricular conduction times via the accessory pathway remain constant, thus enhancing the level of pre-excitation. We hope that you have enjoyed this video with two examples of ventricular pre-excitation. Thank you very much for your attention.